Hi friends, we'll continue with the problems of the design on spur gauge. So let us consider a problem. Design a pair of spur gauges to transmit a power of 18 kilowatts from a shaft running at 1000 rpm to a parallel shaft to be run at 250 rpm, maintaining a distance of 160 mm between the shaft center, such that so suitable surface hardness for the gear pair. So from this problem, what are the given data is? N is given, that is the power is given, N1 and N2 is given, that is speed of pinion and speed of the gear, and they given a center distance. From the center distance, you can calculate the diameters of the gears. So only these are the data they given. So you can assume the material for both pinion and gear as the same, or you can go for a different material. So I am going for the different material. So first I am going to assume that is tooth profile as 20° full depth involute profile. So I am going to take as medium shock 8 to 10 hours per day for the CS. So I am going to go for the material for pinion as SAE 3245, that is chromium nickel steel. So which has allowable stress from between 448 to 517 megapascal. So I am going to assume that as 500 MPa. So velocity ratio. So since they given both N1 and N2, I can get the velocity ratio I is equals to 4. So this is the things I can get. Now they given extra is center distance. In the previous problem, we have taken that mean velocity and calculated the diameter. But in this case, they given the center distance as A. So A is equals to D1 plus D2 by 2. So D1 I going to substitute in D2 I going to substitute in terms of D1 by taking the ratio. That is D2 will be equals to I into D1. So I am going to substitute. I am going to get D1 as 320 by 5. Or I can get D1 is equals to 64 mm and D2 I am going to get as 256 mm. So for a 20° full depth involute profile, the Lewis equation is, that is y1 is equals to 0.154 minus 0.912 z1. So I am going to assume the z1 value here just to find out the weaker member, just as I did in the previous problem. So I am going to assume this values. So 0.1084 I am going to get. So z2 will be 80. So y2 I am going to get as 0.1426. So now I not selected the second material. So to get the second material as for the calculation, so I'll go for the selecting the next material. So to select the gear material, I am going to go for sigma naught 1 y1 is equal to sigma naught 2 y2. So I am going to substitute sigma naught 1 which I assumed, y value which I got, sigma naught 2 I am going to keep as it, y2 I am going to take the previous value. So sigma naught 2 I am going to get as nearly 380.084 Newton per mm square. So from the table, so which are the value which is near to this value, so I am going to assume that. So from the table I am going to make that SAE 4640 as the material, so with the allowable stress as 379 Newton per mm square. So I am going to assume that material for a gear, or you can select the same material for both pinion as well as the gear. So when you go for that, identify the weaker member. So I am going to substitute the values of sigma naught, so 500 and 379. So y value I am going to substitute and I am going to go for the multiplication. So I am going to get pinion as 54.21 and gear as 54.045. From this you can say that the gear is a weaker member, so the design should be based on the gear. So tangential tooth load, so I am going to take Ft is equals to 9550 into 1000 into N into CS divided by N2 into R2. Since D is known, so I can go for R2 is equals to D2 by 2, that is 128 mm. So I am going to substitute, and CS, since I assumed as medium shock and 8 to 10 hours per day, so I am going to take 1.5 again from the table, 23.13. So when I want to substitute all the values, I am going to get Ft is equals to 8057.81 Newton. The tangential tooth load for from the Lewis equation, I am going to substitute the equation, that is Ft is equals to sigma naught 2 Bpy2 into kV. So B I am going to assume as 10 m and P I am going to assume as P is given by pi into m, that I want to substitute over here. And y2 you have to calculate because assumed only to calculate the weaker member. So I want to take the y2 formula again, 0.154 minus 0.912 divided by z2. So z2 can be written as d2 by m, that is 256 by m. So y2 I am going to get as 0.154 minus 0.912 into m divided by 256. So I am going to get an equation, y2 is equals to 0.154 minus 3.562 into 10 to the power of minus 3 module, that is m. So I want to find out kV. So Vm I want to find out. So with the formula pi into d2 n2 divided by 60,000, I want to get as 3.351 meter per second, which is less than 7.5 meter per second. So I want to get the formula again, 23.134a. So kV is equals to 3 by 3 plus Vm for velocity factor. So substituting Vm value over here, I am going to get velocity factor as 0.4724. So substituting all this equation and equating the equation 1 and 2, that is with this Ft equation and the second equation by substituting the values. So I want to get 8057.81, that will be equals to 379 into 10m into 0.154 minus 3.5625 into 10 to the power of minus 3 into m pi into m 0.4724. So by substituting and simplifying the equation, I want to get m square minus 0.02313 m cube should be greater than 9.3. So again I'll go for trial and error method. So I want to assume m as 3 first. So I want to get 8.3755, so which is less than 9.3, so it is not suitable. Trial 2, I want to go for m is equals to 4. So I want to go for 4. Substituting that, I want to get as 14.52, which is greater than 9.3. So hence I want to take that model m is equals to 4 mm. To check whether the model selected is safe or not, I will go for check for the stresses. So sigma allowable, I want to find out sigma naught 2 into kV. So 379 into 0.4724, I want to get as 179.0396. And here finding the sigma induced, Ft by B by 2 into P. So Ft value already calculated. So B value 10 into M. Y2 you have to take the same equation again, 0.154 minus 3.562 into 10 to the power minus 3 multiplied by M. So M I am going to replace with 4 and pi into M, that is pi into 4. By substituting this all the values, I am going to get as 114.708 Newton per mm square. So from this two equation I can clearly say that sigma allowable is greater than sigma induced. So hence the selection of model is safe. So design will be safe. Model is equals to 4 mm. So dimensions I have to find out since I am designing the complete gear. So dimension model m equals to 4. From the table 23.1, so for a 20 degree full depth, so what are the values I want to get? So B is 10 mm, you assumed, so 40 mm, Z1 and Z2 you want to calculate. Z1 I am going to get as 16, Z2 I am going to get as 64, and A center distance they already given, A is equals to 160 mm. So addendum HA, that is 1 into module, so 1 into 4, 4 mm. Dedendum HF, 1.25 into module, so I am going to get as 5 mm. Working depth 2 into m, that is 8 mm. Old depth H is equals to 2.25 m, that I want to get as 9 mm. So S, so pi into m by 2, so pi into 4 by 2, I want to get as 6.2832 mm, that is the thickness of the tooth. So DF1, the base circle of pinion, so D1 into 2 HF I want to get as 54 mm, and for a gear I want to get base circle as 246 mm. FT tangential tooth load 8057.81, which you have calculated. So Vm also we calculated, that is 3.351 meter per second. Velocity factor is 0.724 and a pitch pi into m, that is 12.36 mm. So these are the dimensions you have to specify when you are completely designing a gear. So checking, so I will go for dynamic load. Fd is equals to Ft plus 21 Vm multiplied by Ft plus Bc, so divided by 21 Vm plus root of Ft plus Bc, that is equation number 23.155. So load factor I have to find out. Since the class of the gear I am going to assume as 3. If you are assuming the class gear, you can assume, otherwise based on the Vm value you can calculate from the figure 23.35a. I want to take for the class of the gear as third, that is commercial gears. So and the model as 4, from the figure 23.34 I am going to get error F is equals to 0.0125. So that I am going to take from the table 23.32 for a 20 degree alpha, and steel if I assume. So F is equals to 0.0125. So C value will be 145 kilonewton per meter or 145 Newton per mm. So substituting this values over here, I am going to get Fd is equals to 13242.5 Newton. So now to find out whether the wear load is safe or not, so I am going to go for wear load Fw D1BQK. So Q I am going to go for ratio factor, that is Q is equals to 2Z2 divided by Z1 plus Z2. 2 into 64 divided by 16 plus 64. So I am going to get as 1.6. For a safer design, the wear load should be greater than the dynamic load. So I am going to substitute the formula of Fw D1BQK. So D1 value is known, B value is known, Q value is known, K I am going to keep as it is, and I am going to substitute Fw value as 13242.5. So I am going to substitute the values and simplify. I am going to get K should be greater or equal to 3.233 Newton per mm square. So from the table if you take the table 23.37b for a 20 degree and K value is greater than 3.223, the surface ordnance for pinion and gear I am going to get as 450 BHN and 450 BHN. This completes the problem.